All right, AP Calculus AB, just another video to remind you of the pitfalls and the confusion that you might find. We're asked to find the area between f of x is equal to 4 minus x squared and g of x is equal to x squared minus 4. And I can see how a person could get an answer here. So this is what this function looks like. And so here's what it looks like. This is the first thing I'm going to do is I'm going to set these two functions equal to one another. Is equal to x squared minus 4 because I want to figure out if they're bounded by it. We have to figure out where their intersection is. So first thing I'm going to do is I'm going to find their intersection points. So intersections. First thing, where do they intersect? So they intersect. So I'm going to just move stuff over and end up with, what do we end up with here? Negative 2x squared equals negative 8. I'm not going to go through all that algebra with you. X squared is equal to 4. X is equal to plus or minus 2. Right? So they intersect here and here, and they look like this. So here's the first one. Let's take this one here. Let's take this one here. And we know it passes to the point 0, 4, so it looks like this, doesn't it? So it does that. Like this. I'm not sure it makes that noise, but it does that. And if that's a crappy looking parabola, I'm sorry. And then I'll graph the second one, and the second one is this one right here. And it's right. And it's this one here, passes through this point down here. This is, now remember, this is 0, 4, and this is 0, negative 4. And they intersect here and here. Pretend that worked out perfectly. All right? So this is what my concern is here, that if you took this, if you went to your calculator and you ask your calculator what this looked like, we know now that we would be taking the definite integral from negative 2 to 2, right? So if you're going to take the area of the yellow curve plus the area of the blue curve, then given your calculator, your TI Inspire cast, you might ask this question, right? So here's the first function that we had, and here's the second function that we had. And if I just set it up just like this, I took the integral from negative 2, the definite integral from negative 2 to 2, to get the area of 1, right? This is the bottom one, and then added that to the area of the top one, 0. You'd get 0. But how can you, Nathan, how can you get an area of 0? See how that doesn't make a lot of sense. Now, this is true, but this is not really an area question. So if you're taking an exam, they said, what's the indefinite integral of these two things together? Then it's the net area. And it's not area the way you and I understand area. But on the AP exam, when they ask you for area, they mean it. They mean area. So what I found out as I did my math is that the area in here, Nathan, is like, I want to say it's 10.7, but I'm wrong. I don't remember what the area is, but they cancel each other out. This, whatever this is, whatever the value of A is here, then the value of the area down here is the opposite of that. So when you add them together, you get A minus A, and you get 0. But that's not true because area is physical, right? It's an amount of space, and we have twice as much, not none, right? So the way that you do that is this. When you set, this is how you want to set this up. When you're finding area, and I hope you guys out there are writing this down, you find area. Area is equal to the definite integral, A to B, of the top function minus the bottom function dx. So here, the top function here, I'm looking over here, I'm like, where's the top function? The top function is the yellow one, isn't it? So there, top function minus the bottom function. So that's what we have to see. Then we can set this up differently. All right, so what this is going to look like is this. So we're going to use this plan right here to set this up. So we can see that this one at the top right here, right, is this one. So our top function is 4 minus x squared. Our bottom function is x squared minus 4. So all I'm going to do is just use that formula. I'm going to set it up that way. So I'm going to say my area is equal to the definite integral a to b, but we know, Joel, that it's negative 2 to 2, right? So from negative 2 to 2 of the top function, which we said was opposite x squared. We actually wrote it this way, 4 minus x squared, didn't we? I'm going to put it like this. Minus, and I always put these square brackets to remind myself that I have to distribute that negative sign, x squared minus 4, right, dx, right? Okay? From here, we just simplify. This actually gets easy from here. What they're doing on the AP exam is they're just making sure that we know what they're talking about. So they're gonna provide us with that answer, Nathan, that says 0, and hope that we bite. Because when you look at the picture, I mean, I get it. How this, if this size right here and this size right here are the same amount but opposite numbers, I can see how a person would say that has a area of 0. That's not possible, right? So we have to be careful. All they're trying to do is make us prove that we know what we're talking about. I'm going to go ahead and simplify this. So I'm going to distribute this negative sign, Joel, here to here, right? And that gives us negative x squared. Negative times a negative is a positive, isn't it? Are you with me? So if you look at it, now I'm just going to combine all this crap, that our area is the definite integral from negative 2 to 2. 4 plus 4 is 8, isn't it? And negative x squared plus negative x squared is negative 2x squared, isn't it? Is that okay? dx. dx is the base. It's that change in x. So I think we're getting there. So from here, look, it's always our goal is always to integrate and evaluate. So we're going to integrate through integration, and then we're going to evaluate through the fundamental theorem of calculus. So that's where we're kind of headed right now. So if we integrate this, the integration of 8 is 8x minus 2x to the third over 3. Right, and you can leave it like that, Joel, or you can put it like this, like that. However you want to write it is absolutely fine. As evaluated, and our interval was negative 2 to 2. So this is our integration. And what do we say we're going to do after we integrate? We're going to evaluate. And just so you know, we're going to evaluate with the fundamental theorem of calculus, which says that area is equal to big F of B minus big F of A, parent F, however you want to describe that. And when we do all that work, it kind of comes out looking like this, and I'm not asking you to do it. It comes out looking like this, minus 16 thirds minus negative 16 plus 16 thirds, which is all equal to 64 thirds, which is a hell of a lot more than what? 0. Than 0. And then when you see that on the AP exam, you're like, is it 0 or is it 64 thirds? I can see how a person would just go, you know, it's got to be 0. It makes perfect sense, right? Wow, I wonder what just happened. Right? So we go back. I don't know what that mess was. So we have to remember, here's the key to this whole video, if you're still with us, that you got this. When you see area, do not rush into just taking the integral of one thing plus the integral of the other. Because if there's this negative area down here, Nathan, if there's this negative area down here, this negative area has to be made positive. It's the absolute value of that thing down there, isn't it? Plus the absolute value of this thing. The thing is with this, Nathan, is what throws people off, is that in calculus, usually your professor will start to teach you how to find area over the x-axis. So it makes perfect sense that area is a positive number. And then all of a sudden they throw this in, and we're like, what in the hell are we supposed to do here? This is very doable, right? So remember, to find the area, if you have area under the x-axis, you have to set it up like this, that area is equal to the definite integral a to b of the top function minus the bottom function dx. And you see that's what we did, right? We just started filling in the blanks here. And we said that 4 minus x squared, that would be this function right here. And we said, okay, we're going to take that one. And the one that's underneath of it on this whole interval is this one, and that's this subtracting that out. Okay?